It's a great privilege to be here with you today, sharing my knowledge and experience on the traditional lands of the Muwinina people. I pay my respects to the culture of the Muwinina people and thank their elders and the elders of other Tasmanian Indigenous peoples for their ongoing stewardship of the beautiful lands and waters where we meet today. I'm a Spaceman Paul on GitHub and on music streaming platforms as well. Ask me in the hallway track about my science fiction rock opera or indeed about my chickens. I've been working on ODC software since 2017, mostly with Geoscience Australia, but initially actually employed by CSIRO. I've been a member of the Open Data Cube Steering Council since 2019, before moving to work directly for GA in late 2021. Since then, I've been the main contributor to Data Cube Core, and I'm currently serving a one-year term as chair of the Open Data Cube Steering Council. I'm here to talk about the first new major ODC release in 4 years, but first of all, I need to set the scene with a bit of historical context. The Open Data Cube was originally a joint venture between CSIRO and Geoscience Australia, aimed at making it easier for researchers to work with GA's historical Landsat archive on the NCI being Australia's academic high-performance computing cluster. There were at least 2 earlier abandoned attempts before a successful proof of concept was written by a small team of CSIRO and GA developers that eventually grew into the Open Data Cube as we know it today. It's always been open source licensed. By late 2015, GA had become the main contributor to that codebase, and by 2016 it was declared production ready as the Australian Geoscience Data Cube, or AGDC, released under the Apache open source license. At about this time, the project started to shift attention away from an NCI-only focus to start thinking about running in the cloud, and also the project started to attract international attention. Then in 2017, the project was rebadged as the Open Data Cube and entered a phase of rapid expansion. There were major annual releases for the next 3 years. Secondary cloud-focused software started to emerge, including scalable services for the generation of continent-scale derivative and summary products, and for delivering live map imagery directly from raw data in the cloud. We had an immediate impact with organisations around the world starting to use the Open Data Cube, and also other open source Earth observation projects started to adopt aspects of our approach. This period also saw the establishment of an independent multi-organisation steering council to oversee the governance and development of the ODC project, and also some further contributions from CSIRO. But by 2020, budgets were shrinking and migration fatigue from annual backwards incompatible upgrades had set in. The focus at both GA and CSIRO shifted from core platform development to secondary ODC applications and cloud infrastructure. CSIRO and GA were nominally working independently this time, but engineers from both organisations were talking to each other regularly, and code and ideas were shared freely. Attention also shifted to packaging smaller tools that interoperated more cleanly with the emerging open source cloud-native Earth observation software ecosystem. ODC Geo, based on the Open Data Cube geometry utilities, and ODC Stack, based on the Open Data Cube loading code, both appeared towards the end of this period. But other than bug fixes, the Open Data Cube itself saw little change. This takes us through to about 2022, shortly after I moved to Geoscience Australia. So let's take a quick review of the challenges and opportunities that I saw facing the project in mid-2022. A lot of people had moved on, and a lot of expertise in a complex code base had simply been lost. But on the other hand, some of these people were contracting their specific ODC knowledge to other organisations to work on ODC-related code. ODC Geo and ODC Stack in particular benefited greatly from this. And other people, like myself, were starting to move back and forth between the ODC teams at GA and CSIRO, improving communication and mutual understanding of both organisations' distinct but overlapping interests and priorities. Apart from a few isolated exceptions, the vast majority of development on the core Open Data Cube libraries was still coming from within one organisation, Geoscience Australia. This is not a healthy or sustainable state for an open source community. But on the other hand, we had a growing international user base of potential collaborators and contributors. And I'm happy to say that a couple of years later, we're starting to turn this around. And although GA will certainly remain the main contributor for the foreseeable future, we are seeing more and more external PRs starting to come in. That rapid growth phase and the upgrade fatigue that followed it had left us lumbered with a lot of lingering technical debt. And the spin-off of ODC Geo and ODC Stack raised obvious concerns about the possible fragmentation of the platform. But on the other hand, the successes of ODC Geo and ODC Stack represented opportunities to be capitalised on, and they stand as exemplars of what can be achieved when technical debt is retired. The most obvious example of technical debt was a confusing and poorly optimised database schema. Open Data Cube utilities with heavy database usage, such as OWS and Explorer, were managing extensive database schemas and indexes of their own simply because the core index layer didn't provide the features and services that they needed. In particular, the existing spatial search implementation was completely broken for datasets that crossed the anti-meridian or the polar regions. And we had projects like Digital Earth Pacific and Digital Earth Antarctica emerging, with strong interests in both these problematic regions. But on the other hand, the fact that we did have this strong interest from inside GA from an emerging program helped to build a forceful case to management for major enhancements to happen. We also had Landsat Next starting to appear on the horizon with greater temporal and spatial and spectral resolutions and the resulting demands that our platforms be able to scale to much larger data flows. We also had strong interest from CSIRO in improving the scalability of the Open Data Cube for emerging hyperspectral satellite platforms, which have even higher resolutions and greater data flow rates than Landsat Next. So here we had an opportunity emerging for a major external contribution that would directly assist with GA's strategic priorities. But the elephant in the room that I've been dancing around a bit so far is that the past history of cooperation between CSIRO and GA over the Open Data Cube development has been pretty rocky and fractious. But on the other hand, the relationship between the GA and CSIRO ODC teams in 2022 was the closest it had been for many years. There are former DEA staff working at CSIRO and former CSIRO staff working at DEA, and through the Steering Council we have an independent vehicle to maintain those relationships and to balance competing priorities. And finally, and most importantly, we had a powerful and mature open source cloud-native Earth observation data platform, and what an opportunity that was, and indeed still is. So by 2022, the main areas of the Open Data Cube in need of work were well known to the Steering Council. Many passionate discussions have been had and several enhancement proposals have been drafted. Enhancement proposals being the formal mechanism for Steering Council approval of major changes to the Open Data Cube. In late 2022, I consolidated those discussions and enhancement proposals into the ODC V2 roadmap, a strategic long-term plan for ODC development. After further consultation and redraft, the roadmap was approved by the Steering Council and subsequently fleshed out with more detailed enhancement proposals. The roadmap was mostly focused on a managed gradual replacement of the index database layer. It proposed using the powerful but underused ODC plugin architecture to allow a staged cutover. So the idea being that 1.8 versions would support the legacy backend only, 1.9 versions would support both the new and the old database backends, with an eventual 2.0 release dropping support for the legacy databases. We also targeted ODC Geo reintegration and CSIRO's multidimensional hyperspectral loading code for 1.9. Where possible, we manage other backwards incompatibilities in the same manner. We add the new approach and deprecate the old in 1.9 and then remove the old in 2.0. But where we have to make breaking changes in 1.9 in order to make progress, we're not afraid to do so. But we do strive to keep migration as easy as possible. So let's have a quick walk through the main changes coming in DataCube 1.9. So again, in 1.9, there'll be two main database backends, or index drivers as we call them, the old legacy Postgres only driver and the new PostGIS driver. PostGIS is an Postgres extension, of course, so they're technically both Postgres drivers, but that's the terminology we're using. There's definitely room for other new index drivers to be developed as well. A Stack API-based driver is one obvious possibility. While the legacy driver only supports lat-long bounding box search, the PostGIS driver supports alternate CRS and arbitrary polygon spatial search through PostGIS spatial indexes. This allows fast and accurate geospatial search in the native CRS, bypassing the anti-meridian and polar issues, at least for the search use cases. The legacy driver managed its own schema, which left it very brittle to change. The PostGIS driver, on the other hand, uses Alembic to provide managed schema updates, making it much easier to deploy database schema changes going forward. Some breaking API changes are being piggybacked onto the index driver transition. For example, the legacy driver supports legacy metadata formats and the legacy lineage API, while the PostGIS driver requires EO3 compatible metadata as a minimum and uses a new lineage API. So why a new lineage API? Lineage information, so which data sets are derived from which, is an important aspect of collection management, especially for large complex collections like DEA. Previously, we could only track lineage relationships within one index, and lineage data was tightly coupled to the main database table, complicating the indexing process. The new API allows users to track lineage relationships in a multi-database environment, and it also allows for a simpler decoupled schema structure and a more modular and more powerful API, which is all documented in Enhancement Proposal 8, if you're interested. We weren't planning to deal with the configuration layer in 1.9, but in the end we didn't have any choice. The old implementation was complex, inconsistent, undocumented, unmaintainable, and the complete rewrite was really the only way forward, with full backwards compatibility being not only impossible, but frankly undesirable. Previously, config files from multiple locations were merged. This was rarely used deliberately and was very confusing when it happened accidentally. So we've moved to reading from a single config file only. We now support JSON and YAML, as well as the old INI format for configuration files. This opens up the possibility of hierarchical structure in config in future. Configuration environment variable, in 1.8 was available, but it was arbitrary and inconsistent, and in particular, it didn't support multiple database use cases. In 1.9, we get a consistent, universal and extensible approach to configuration by environment variable. These do-wins do come at the price of stricter rules on configuration environment names, but affected names should already be getting deprecation warnings in recent 1.8 releases, if that affects you. Full description of the changes, Enhancement Proposal 10. 1.9 will welcome ODC Geo back into core, giving us a free major upgrade of our geometry library, both internally and for end users. The ODC X-Array extensions that ODC provides are a huge productivity booster. ODC Geo is used internally throughout Core 1.9. The old datacube.utils.geometry library is still present, but it is deprecated and will eventually be removed. The biggest issues to be aware of when migrating code from datacube.utils.geometry to ODC Geo are the XY coordinate ordering and the construct and signature for the GeoBox class. In both cases, I think you'll find the ODC Geo form is simpler and more consistent. Both ODC Geo and Core provide helper classes and compatibility hooks to help make migration even easier. And finally, there's Enhancement Proposal 11, multi-dimensional loading for hyperspectral data. Many new hyperspectral algorithms require spectral frequency to be loaded as a fully fledged dimension alongside X and Y and time. This is the most significant contribution to the ODC from CSIRO, or indeed from outside of GA, since the very earliest days of the project. It's based on enhancements to the loading code in ODC Stack, so it also represents a partial reintegration of that library. The new code supports new file formats like ZAR and allows flexible dast chunking and dimension ordering. Using these enhancements currently requires having ODC Stack installed, but we do intend to split the loading code out into a new shared package before the 1.9 formal release. So that takes us to status. Pre-releases of DataCube Core and OWS for 1.9 are available now on PyPy for early testing. Other key packages like Explorer and DC Tools are also nearly ready for 1.9 release. The other ODC packages will be migrated to 1.9 after the initial release. The release of 1.9.0 is now mostly waiting on documentation, particularly around the migration process, and a few other minor cleanup tasks like splitting the new loading code out of ODC Stack. The main migration challenges for users on upgrade will be dealing with the configuration changes and the migration to ODC Geo. You can expect to see a lot of deprecation warnings on upgrade, but dealing with them and migrating to the new index driver can be staged and postponed as needed. We are a very small team and there's still a bit more work to do, but we are very confident that we'll be able to release by the end of the year. We recognise that major upgrades can't be rushed, and the 1.8 series releases will continue for some time after the first 1.9 series release. We will be dog fooding DataCube 1.9 at GA and feeding what we learn back into development. Work on 1.8 will focus mostly on making migration to 1.9 easier, and meanwhile on 1.9 will focus on porting and upgrading the remaining libraries and applications, and tuning performance of new code, and of course bug fixes. We like to pretend they're not there, but that's going to happen. We're also hoping to grow the team in this period, both within GA and in the broader community. And we will continue to consult with the community about priorities and requirements for version 2. We won't be starting work on 2.0 in earnest until the 1.8 series has been end-of-lifed. This could be as early as mid-2025, depending on how the 1.9 rollout goes and how much and how fast we can grow the team. The key focuses for 2.0 will be continuing the architectural cleanup and the retirement of technical debt, started with 1.9, on Landsat Next requirements, and on improving interoperability between ODC and Stack. Other focuses and priorities will emerge from consultation with the community, and I encourage you all to have your say. What would you like to see from ODC2 and beyond? If you want to learn more or get involved in the community, I invite you to join our new Discord server. We're currently migrating our community support from Slack to Discord. The Steering Council currently has subcommittees working on documentation and community engagement. They're both great ways for newcomers to get involved. The monthly meetings for these subcommittees are held on Discord, and all are welcome. We have a friendly and supportive community and a powerful and mature open source cloud-native Earth observation data platform. These are both powerful opportunities for you, and I encourage you to take advantage of them in your Earth observation work. And I'm a little bit ahead of time, but come help grow our team, either within GA or within your own organisation, or just in your spare time. We would love to see more involvement from the community. Oh yes, you start Friday morning, on Friday afternoon, Friday morning. We've got a Friday all day of the community day. We'll be doing a bit of an ODC hackathon, working on stuff together. So join us for that as well.
Thank you, Paul. Does anybody have any questions? Thank you.
Thank you. Yes, Alex.
Yes, Alex.
Not a question, more of a statement, but the good type. So I just wanted to recognise, Paul, all the stuff that you've done. It's like in the background, low-level, like hard code problems that you're tackling, and as a consumer of the Open Data Cube and the ancillary tools, I just want to say that you're doing a great job, and thank you.
Thank you, Alex. I think the thing I'm most proud about is the community work, that getting CSIRO and GA working friendly together. I think that was probably a bigger challenge than a lot of the technical ones in many ways.
One more.
And Caitlin.
It's also a statement. I'm the current chair of the documentation subcommittee, so if you do use the Open Data Cube at all and you think the documentation could be better, you are not alone. I also think that, which is why I'm trying to... You're not sorry, Paul. Paul already does a lot of stuff. He can't be the only person who does things, so that's why we exist. But if you do want to talk to me about it, please come and talk to me about it. And as Paul said, yeah, we'll be hanging out on Friday here at the conference centre doing ODC things. So we'd love to see you there.
Any more questions? Brianna.
Yeah, I think I asked you this last night, but I'm just wondering, how do we make sure people like you get funded to keep doing the work that you're doing?
That's a question I'd love a good answer to at the moment. Yes, so it is difficult. I think we were very lucky at GA that we had these visionaries working in 2017, 2016, 2017, who saw the potential of the code that we were writing and promoted them heavily. There is a difficulty that you end up with most of the people doing the work being contractors, and then when budgets drop, they leave, and suddenly you've got no one. You just lose this knowledge. So yeah, it's difficult. You really have to bring people like me into the public service, I think, into direct employment by the government. That's very difficult to do because we can just earn so much more in the private sector. So I think you really do have to appeal to our better natures and make it clear that we are working for the common good and to make the world a better place, and not just putting money in our bosses' pockets or our investors' pockets. I think that's probably how I'd respond to that.
Thank you. I have another question. For current users, what are some of the potential challenges or adjustments they might face with the migration to ODC version 2?
So it depends on what your code is like. I think that most users will see not a lot of impact. They will see a lot of warnings coming up saying, don't use this API method anymore, use this other method instead. But it does tell you what to use, and hopefully you'll see the logic as you go. The move to ODC Geo will cause some issues, but it's pretty smooth for that. There are a lot of little helpers to make it easier, and I think probably 80% of users will. I mean, that code will just work. They'll just get these warnings telling them to fix things up, and we try to make those warnings as helpful as we can. But if you're messing around at the low level, if you're actually calling the old configuration API methods, or if you're dealing with a database directly, then you'll have a bit more work on your hands. But I think most users will be fairly transparent.
Thank you. Any more questions? Okay, thank you, Paul. Round of applause, please.